Hi, I'm Cody Kinsey, and today we're going to go over Wi-Fi self-defense. We are going to explore ways that you can improve the Wi-Fi security of everyday devices like your laptop and your phone, and we're going to use them as a lab to learn a little bit about offensive hacking and how you can be prepared to both detect and respond to Wi-Fi hacking attempts. In order to participate, you're going to need a Wi-Fi nugget, and you'll also need a laptop that has Chrome installed. Once you have these, then we're ready to get started. So you can find these slides online, but we're going to talk about our objectives for today and a high-level overview of what we are going to learn. So first off, my name is Cody Kinsey. I am a security researcher that focuses on Wi-Fi. So I really like Wi-Fi signals intelligence. I like figuring out how it works and also conducting Wi-Fi investigations. And that means I know a lot about all the various ways that I can sniff information or otherwise learn about your Wi-Fi devices. So one of the goals of today is to use my experience as Wi-Fi researcher to teach you how to keep your devices more secure. So I teach on a lot of different channels. You might recognize me from the Nullbyte channel, which has almost 1 million subscribers, but I also teach on the Security Forward channel, Retia, and also I've been on the Hack5 channel as well. You can find out more information about me or continue to watch my content on hack.gay. All right, so we are going to use a number of resources today, and one of them is a text-based version of some of the scripts that we're going to be talking about. So if you are more of a copy and paste type person, then I've got you. Over here, we have a GitHub repository that has all the scripts we are going to use, supplementary information. So if I say that I want to use, let's say, the beacon swarm command, then I've actually written that out for you, and you should be able to just select the raw version of this and copy and paste and take some of these really big commands that you don't need to do them yourself. Or if you're getting an error, then this should help you be able to understand maybe where that error is coming from. So hopefully this will be useful for you. I've got a couple of other resources available as well, but just do not worry if you are maybe having a little bit of difficulty at first. Okay. So you can also find access to the serial terminal. Now, again, you're going to need Google Chrome in order for this to work, but we are going to use Web Serial in order to get everything working together. So you can pick from a number of different websites that do this, but I like serialterminal.com. You can also go to serial.hun.me, that's H-U-H-N, which also works very well, but because of the way that it scrolls, it's not very easy to see in this demo. So I'm going to be using serialterminal.com instead. We're also going to be going to nugget.dev. Nugget.dev is our tool for flashing. This is going to give us access to all of the cool programs we're going to be putting onto our Wi-Fi microcontroller. We've already compiled them. We've made it easy for you to flash them. So this website is going to be responsible for actually doing the flashing, which means you don't need to do the command line. We used to teach this class using command line. It was a little bit of a pain, honestly, and a lot of people had difficulties with it. So the fact that a browser can take care of that for us now is going to really make things a lot easier for everyone. So before we get started, we're going to do some things today that could be unethical if we do them without permission. Now, we have implicit permission to test out the Wi-Fi on our laptop, on our own cell phone. However, if this is someone else's wireless device, you need to be aware that some of the attacks we're demonstrating today could constitute a crime. So when it comes to ethical hacking, I just need to confirm that everybody understands if you start attacking or modifying the way a device works that is not your device, you might be committing a crime, especially if you're denying them access to service or if you accidentally break something important. You never know what Wi-Fi devices around you might be doing a really important task. So it's essential for you, before we continue, to confirm that you understand how ethical hacking is ethical. Now, what I mean by that is that ethical hacking means you get permission and consent to do something to a device before you do it. Now, as this is a Wi-Fi self-defense class, the understanding here is that you're using your own devices. So before you apply these techniques to other devices, just be aware you will need permission, because if you do some of these, especially at work or in a place that is monitored, you will get a lot of attention very quickly. These are loud attacks, or at least some of them. I'll let you know which ones generally, but just be aware that anybody monitoring a Wi-Fi environment will detect these and might find them to be very suspicious. So unless you want to have a conversation with Homeland Security, please do not do these, for example, at airports or other sensitive locations, and certainly only do this against your own devices. Once you all confirm that you understand, then we can proceed. Now, again, this is a very useful thing to do. Making sure that your devices are hardened against attacks is the point of this class. So we're going to use our own devices, especially cell phones, tablets, or laptops, as the target of this class to make sure that we're doing it in a safe and ethical way. So what attacks are we going to learn about today? Well, first we're going to talk about the data that your cell phone is leaking all of the time. The things where if you leave your Wi-Fi just on, it is constantly revealing about where you've been, where you work, and possibly other information that you don't want getting out there. We'll learn about the way that this works and how to stop it by doing some scans that reveal this information just kind of flying around in the air. And this is a very passive attack. You can do this attack, well, it's not really an attack, but you can do this monitoring basically anywhere. And because it doesn't involve outputting any active signals, it should not be detected and is very safe to do. Next, we're going to use Wi-Fi beacons to pull information out of phones around us. So by that, I mean we are going to target nearby devices with fake networks and see if any of these nearby devices recognize those networks. If they do, then we can get those networks to try to connect to us, and we can also confirm that that individual who owns the device might be part of an interesting group, like maybe a government organization or maybe a contractor that is working on some really interesting stuff. So as a targeting profile, I once used this as the basis of a JPL, Jet Propulsion Lab, employee detector, and made it so that a little buzzer went off every time someone who worked at that organization walked through a door. It is totally possible to do things like this, and I'm going to explain how that works. We're also going to talk about tracking the location of smartphones via evil QR codes. So if you've ever felt a little maybe suspicious of scanning a QR code on your phone, I'll show you why this might actually be a problem. If you scan an evil QR code, then it can cause you to join a network that modifies the behavior of your Wi-Fi device, your smartphone. In this case, it joins a malicious network that constantly beacons out, tagging your device like a tagged animal and allowing you to track the location by signal strength and also by the fact that it's constantly calling out this network name over and over forever. So we'll learn exactly what this looks like and how to remove it if you might have accidentally fallen victim to this attack. We're also going to go over a Wi-Fi phishing attack, and this is something that I have fallen for personally. We're going to learn about exactly how this looks and how you can spot it, and why this social engineering attack is so popular amongst hackers when it comes to stealing Wi-Fi passwords. So let's go ahead and talk about the details of each. So for Wi-Fi leaks, we have a setting in our phone that is constantly trying to geolocate us and also find available Wi-Fi networks to connect to. This saves us cellular data, and it is pre-programmed into the behavior of smartphones to constantly be searching for nearby Wi-Fi connections. Now, for devices that don't have cellular data, like a tablet or a computer, then we have this same need to always be looking for a data connection. And, maybe we're moving from place to place and we're looking for a constant list of networks to connect to. This process is ongoing, and we're going to take advantage of that as hackers to learn about networks that devices nearby have connected to in the past. Now, this opens a lot of doors. It allows us to potentially create fake versions of those networks and capture the Wi-Fi traffic of that device. And it also allows us to poll around nearby and try to find out whether somebody who works at an interesting place is operating in the area. Now, what's cool about this is it's very difficult to turn off. And even if you turn on airplane mode, if you don't turn off assisted GPS, you can actually still do this. So we'll talk a little bit about what assisted GPS is and why you might not actually be silencing your Wi-Fi radio when you turn on airplane mode. All right, so the next attack we're going to talk about is beacon swarms. This is large groups of fake networks that we can easily create with our Wi-Fi microcontroller. Now, this is going to be interesting because the default behavior of any device like your smartphone is to constantly be looking for nearby Wi-Fi networks that they might recognize. If they do recognize one, aka if we create a fake network that your device has joined in the past, it will attempt to automatically join without even asking you. And that gives us, the attacker, an idea of what you might have been up to. maybe it's a location you went to in the past, an airline you flew on, or a company you work for, this attack will allow us to create fake versions of any network and do it at scale. We'll be able to create up to 100 fake networks. So if you've got any ideas for this, then you'll be able to create custom Wi-Fi names that everybody around you will be able to see. Now, this is the first attack we'll be covering that is active, meaning if you're doing this in an area that is monitored, this is extremely obvious to spot and may arouse a lot of suspicion. Next up, poison QR codes. We're going to be abusing the hidden feature of Wi-Fi networks. Now, if you've got a paranoid uncle that has been setting their Wi-Fi network to hidden, this is the consequence of that action, where any device that's joined to that network is actually screaming out that network name over and over. We're going to weaponize this quirk of Wi-Fi and make it so that a QR code conceals the fact that we are adding a device to a hidden network, meaning anything that scans that QR code and joins the Wi-Fi network will constantly start calling out that network name and also automatically join any network that has a matching name. That lets us modify the traffic, start to see what's going on, or even perform a phishing attack on whoever is subject to this attack. So it's a very, very interesting man-in-the-middle attack, and is the first one of these attacks that is very clearly malicious in the appearance to anybody who's monitoring. So if you're doing this in a restricted area, please be aware that this kind of attack looks like it could be something fishy going on. So finally, we're going to go over the most offensive of these, and that is a Wi-Fi phishing attack. Now, the reason I want to cover this is because I've actually experienced it in the wild. And what's going on here is we're going to simulate that our router is rebooting or is updating and requires the Wi-Fi password in order to proceed. Now, we can disable the Wi-Fi of our target and then pop up this fake Wi-Fi network that pretends to be the router needing a password to apply an update. The average person probably doesn't know that their router doesn't really do this and will just enter the password in order to get access to their Wi-Fi again. This is a pretty sophisticated attack, and like I said, I've fallen for this before in the wild, and I want people to be aware of what it looks like and exactly how easy it is to do. This is really one where if you get caught doing it against a target that doesn't give you consent, you can get in a lot of trouble. So please make sure that this is the one in particular you are paying attention. You're only doing against your own devices. So first off, what is the tool we are working with today? I'm going to show off exactly this little demo here, and this is our Wi-Fi nugget we're working with, but really we can work with any device that runs the ESP8266 to complete this class. So if you are not rocking a Wi-Fi nugget on this particular go around, do not worry about it. That is totally okay. So we can see here, this little microcontroller can do a lot of stuff. It's running a screen. We've got this antenna, which actually is for Wi-Fi. A microcontroller is kind of a step down from something like a Raspberry Pi. Now, a Raspberry Pi is a full-on computer, and it's something that can run an operating system, whereas these little microcontrollers instead run custom firmware that we compile and then load on them in a bin file in this case. So if you want to know the difference between the two, this little microcontroller, in this case the ESP8266, cannot run an operating system, but can be programmed to run a Wi-Fi radio and also things like a screen, buttons, and other peripherals to make it easier to use. So our Wi-Fi nugget is an attempt to build this out and make it a little bit more useful, but the core microcontroller here is all that we need to do a lot of Wi-Fi magic. Now, why is this so cool? Well, basically this Wi-Fi radio was created at a time where nobody really thought about the bad things that you could do with these Wi-Fi radios. So there were no restrictions built into them. And the company that made this, Espressif, did not program any restrictions into the way that these microcontrollers could send data. And that means we can use these Wi-Fi radios to effectively lie. We can use them to create the appearance of many Wi-Fi networks. We can use them to send arbitrary packets that say basically whatever we want. Now, Wi-Fi is very vulnerable to this, and we're going to talk about why during each attack. But the idea is that this microcontroller is perfect for most of the Wi-Fi attacks we want to demonstrate today. So the fact that we built it then into an easy-to-use microcontroller tool to follow along is why we're doing this class today and why we created the Wi-Fi nugget to make microcontrollers more fun for beginners and easier to use. Now you can program these in languages like Arduino, MicroPython, and CircuitPython. CircuitPython does not work on this particular microcontroller because it's a little bit, I don't want to say primitive, but it's a little bit of an older microcontroller that is, I think like 7 or 8 years old now. So it's getting up there in age. That might be a little older, but it'll probably be accurate by the time you see this class. So, all right, if we're working with these little microcontrollers and the built-out version is the Nugget, then, what are the features of the Nugget versus just a microcontroller by itself? Well, as you can see, we're using the D1 Mini, which is already a breakout board of the ESP8266. The little postage stamp size microcontroller here is what is the brains of the operation. And that has been soldered onto a slightly larger board, and that larger board is what actually makes it so it is accessible for people to do hardware hacking with and all sorts of other cool things. So we've added a screen, buttons, and GPIO pins on the back in order to make this breakout a little bit easier to use. So it's kind of a breakout, you might say. It's also got an LED indicator, which I have muted by putting some tape over because it is incredibly bright in this default version. And the idea here is that you can do add-ons. You could plug things into the back like a LiPo add-on to make it so that you can use it with a battery. You can put it in a case to be a little bit more protected, and then it operates a little bit like something like a Flipper Zero. But this is supposed to be something that turns a microcontroller into a tool that anybody can use without necessarily needing to plug it in. Now today, we're going to be plugging it in. And the reason for that is we're going to be using the advanced features, where we're basically using our computer here over the web interface to control this microcontroller at its lowest level functions. And we're going to be using its Wi-Fi radio to do some pretty powerful things. So there are multiple versions of software that can run on this device, and that is kind of the point of what we're doing today. We're going to be flashing a different version of this than what typically comes with it. So if I go over to this Nugget fan cam and you see that it is running this Nugget Deauther, this is the version 2. And this version is able to do basically everything that it wants to do without needing to be plugged into a computer. It just needs power. You can add a battery to it if you want to with a LiPo battery pack and make it so that it is operating independently. But because it is using so many resources, both for that and also for a snazzy web interface that's available if I wanted to connect to it, it doesn't really have the capacity to do some of the offensive stuff that we want to do, which is unfortunate because I really want to do some bad stuff with this. So we're going to flash a different type of firmware to it. We're going to flash the Deauther V3. So this is the V2. We're going to be flashing the V3. And when we're done, when we plug it in, the screen will not turn on anymore. And the reason for that is we're using all of the resources available from this little microcontroller to do Wi-Fi hacking stuff instead. So if you follow my instructions and then suddenly the screen does not work, do not panic, don't get upset. It just means that you are following along correctly. So what is the difference between the V2 and the V3 Deauther? Well, with the V2, you get this web interface, the display support, and you'll notice that those are missing in the V3. Instead, you get some additional things which are actually cut off by me in this particular slide, but all the other things are kind of checked on the rest of this here. You get a rogue access point, authentication scanner, signal string scanner, which means fox hunting and tracking down individual devices, and then support for serial programs that are including the Hunator. So we are going to be upgrading to the V3 today. Let's go ahead and get this done so we can see exactly what it looks like to flash something via nugget.dev. So go ahead and open up your Chrome-based browser, and you will be able to navigate to nugget.dev and rely on the website to accurately identify and then flash to your device. So I'm going to show exactly what that looks like. I'm going to unplug my device for now. Let's go ahead and flash our device, and we're going to do it live. So this is the nugget.dev website. I am going to plug in my Nugget. So let me show you exactly what that looks like. This is going to be our test Nugget. I'm going to plug it in. All right, and currently nothing's going on. I hope this Nugget's healthy. I guess we'll see. And I'm going to click on Connect My Nugget. And here I have the USB serial device. If I'm not sure which is which, then I can always unplug my device and plug it back in. And generally, it'll be the one that appeared and disappeared. Kind of a easy trick to follow. So I'll click on Connect, and this should give me a list of all the different firmware that is available for this device. And in this case, I want to pick the one all the way at the bottom, the Advanced V3 Deauther, and it says no screen. That is a hint that as soon as this is working, then I should not see a screen. I can click on Erase if I want to be thorough, and this will get rid of any program that might still be on the device. I do this as a force of habit just to make sure that there's nothing lingering there. I'll hit Program, and if it kind of like instantly flashes over, that's too fast. It should take somewhere around the amount of time that it's taking my device to flash right here. If it flashes like instantly, then maybe check your USB cable or your browser, because that generally means there might be an error. In about, I would say 30 seconds, it should be completely done flashing. And in order to get it working with the new firmware, you'll need to unplug it and plug it back in. And when it powers back up, you should be able to connect to it via the serial terminal. So that doesn't really take that long. And again, if it goes too quickly, then maybe be a little bit suspicious of it. Okay, it has finished. I'm going to unplug it and plug it back in. And I can see now when I plug it back in, it does not turn on the screen. There's no screen turning on. And that might alarm some people, but I know that it's actually good. That means that I've successfully flashed the new advanced version. So here I can see there is a serial terminal. I'm going to connect the nugget. And then in order to confirm it's working, I can type help and press enter, and I should get a list of all the different commands. So if I type help scan, then I get a list of all the different commands available for the scanning function. There we go. So that's a positive indication that everything's working. This is one of the serial terminals you can work. If you have any problems, you can also go to serialterminal.com. There we go. I'll click on connect. And then if I type help, I should see all the same stuff right here. Okay, so we have successfully flashed our nugget. We are now connecting to it over serialterminal.com, and that is it for the setup portion of our class. If you thought that was short, that's because it is. Most of this process is set up for you, and all you need is the serial terminal via Chrome to get started. If you want to explore some of the commands, you can type help and then get a summary of all the different commands for each of the things you are going to be doing today. And of course, if you want to type chicken, this is also a great test to make sure that everything is functioning fine and also just kind of generally boost morale. Let's begin our first lab. The first lab is going to be covering the various leaks in Wi-Fi devices and how we can get started plugging them. And in order to do this, we're going to be using our new advanced Deauther to perform some basic scans. Now, the most basic scan is just typing scan. So I'm going to type this into our terminal here after I enlarge it. And let's take a look at what this looks like to use. All right, so initially, when we run the scan command, we're going to see a number of things that are not ideal. Now, by not ideal, I mean we might be scanning channels that are literally illegal to use in the country that we're in and wasting time when we're really more interested in a couple of specific channels. So we're trying to find things that are leaks, basically, like Wi-Fi disclosures that are not intentional. And here we can see we ran a basic scan, we found 2 Wi-Fi networks, and that was all. A pathetic result. That was not something that was really indicative of a thorough Wi-Fi scan. So if I type help scan and amplify the results a little bit, I can see that we have a number of different, let's just say, levers we can pull and move around in order to improve the results of our scan. So how do we build an optimized scan? And what do these results, or what do these levers mean? Well, these are flags, and we can use them to modify the way that the scan works. So if I say scan and then start using some of these like -M, This specifies the mode of the scan. And in this case, we're going to say we want to do a station scan instead of an access point scan. So the difference between a station and access point scan is that a station scan will scan for Wi-Fi devices like my phone, like my laptop, that are connected to a Wi-Fi network or looking for a Wi-Fi network to connect to. Whereas an AP scan will focus on devices that are creating an access point. And that's going to be something like a router or maybe a phone that's got its hotspot on. So we want to specify that we want to do a station scan, but we can get a lot more specific than that. We can also specify the time in seconds that we want the scan to run for. So if we say -T for time and then 60 seconds, we can say that instead of the default 20-second scan, we want it to run for 3 times longer. Now, next we can specify the channel. In the previous scan, we were scanning channels that are not even legal in the United States, like channel 14. So if we put -CH and then 1, 6, and 11, these are the most common channels that devices in the United States use, and it can greatly speed up the scan to run these 3 non-interfering channels, because most of the time Wi-Fi devices drift to these 3 non-interfering channels because basically in our Wi-Fi system, anything between these actually kind of overlaps and can create interference. So these are the best and most popular channels in the United States. If you want to do a different format though, you can do 1 to 11, 1-11, and it can interpret that as well. So next up, we can do -CT. This is channel time. This is talking about the amount of time that we spend on each channel. And if we have a device that is broadcasting intermittently like a phone, then this is something that we really need to pay attention to, because it means we can be not spending enough time on a channel to accurately pick up a Wi-Fi signal from a client device or from a station device. So let's say we want to set a station time, and this time it's in milliseconds. So if we say 5,000, so that's 5 seconds per channel. It's a little weird that it's in milliseconds, but that's fine. So 5,000 milliseconds is 5 seconds, and that means we're spending 5 seconds on every channel between channels 1 and 11. And that's pretty much it. That's what we're going to run for our scan. So I'm going to press enter. And if you want to follow along with this, we can see that there is a clear example right here on the GitHub repository. So this is going to be under probe reveal.txt. So if you want to follow along and just copy and paste this, you can do so from the GitHub resource. So this is running a scan, and I can see that there are probe requests here. I'm also going to unlock my phone. And if you're looking to see the result of a device starting to send out a bunch of probe requests, then unlocking your phone is probably the easiest way to do it. Unlocking a smartphone causes a barrage of Wi-Fi activity, and it's where you're likely to see things like this. I can see that one of these devices is sending out probe requests. That's almost definitely my phone, seeing as it's coming from DEF CON 69. These are actually previous versions of this class that I've done. So this is showing that my phone is effectively tagging itself and revealing information about where I've been in the past. I can see that it's connected to a local network. It's connected to Data Demons, DEF CON 69, and Zootown class. So we're starting to see that devices around us are calling out and trying to connect to networks they've connected to in the past. Now that gives me as a hacker a lot of information. It tells me where these devices have been. It tells me possible affiliations with organizations. And this is the core of what we're going to be talking about today when we are doing these advanced scans. So you can modify the various aspects of the scan. I'm going to copy and paste the one that's available in the GitHub repo. And it is very, very easy to start picking up Wi-Fi signals indicating, oh, there we go. So this is a really big one. So we now see what happened to my MacBook when I did this. And it's kind of over. Wow, that is a lot of information. So let me minify this a little bit. We can see that my MacBook actually gave up way more information than my smartphone. And I want to explain these results a little bit. So we see 2 different MAC addresses, and this is because my device is doing something called MAC address randomization. So it groups these requests together, and then it sends them, but it changes aspects of the MAC address to try to appear to be a different device. Now, obviously, I can figure out that it's actually the same device if it's sending out the same networks over and over. But here, what's cool is I can see that I've been in a convention center. I can see that I have joined the Wampus Nugget network. And I can see some of these other networks that are also stored in my device that are being called out over and over. So how is this happening? How can I see the Bifrost, a hotel that I stayed at? Like, how can I see all this information about my devices, and how can I help keep this information more private? Well, this information is not very valued by your devices. They think that this is a normal part of the process of connecting to a Wi-Fi network to just shout these out, even if they uniquely identify you as maybe a government employee or a contractor or somebody who other people might want to hack. So it is in your best interest to, hide up conceal your data if you don't want it out there. And we'll go through exactly why this is happening. And it's generally a list that looks a lot like this. So this is my personal list of shame. This is all of the Wi-Fi networks that are stored in my phone. And what's interesting about them is the majority of them are open Wi-Fi networks. So I'd like you to go ahead and take a look at all the networks that are stored in your phone and see whether or not there are open Wi-Fi networks there. If there are, take a moment and delete them, because it means that anybody can not only do this attack to determine that you've connected to them before, they can also create that fake network and trick your device into joining, and then potentially do pop-ups on your phone or start doing other phishing attacks. So you'll need to go through and remove these networks in order to make sure that the ability to just create a bunch of fake networks doesn't cause you to accidentally connect to one of these networks, because anybody can just listen in and hear which networks your device is calling out for, and then use what we're going to do in our next lab to take the active step of attacking those devices. So far, this has been a passive attack. We have used the scan command to listen in on devices nearby, and we've optimized that command by using some of the available flags in the V3 Deauther. If you want to pause and improve your own security until your device does not respond to this attack in the same way, that is the point of this course. So go ahead and make sure that you remove these hidden devices from your smartphone or from your computer by going through and finding all these unremembered, unused, and very frankly not very helpful stored networks that you might have accumulated over the course of time. Now, you also might see some that you didn't even connect to on this particular device, and that's because very frequently your iCloud account or your Google account will back up these access points and move them on over to new devices that you joined. So this debt of Wi-Fi networks that are constantly being shouted out by your device might actually go back a really long time. So you want to make sure that your computer hasn't helpfully hoarded these networks and created a very long list of networks that your device is constantly screaming out, uniquely identifying your trail through the world. Okay, let's go ahead and take a look at our second lab, and this is going to be tracking devices with beacon swarms. So beacon swarming is a technique that I started using when I was in Los Angeles and I wanted to ride on subways and create a bunch of fake networks in order to see where some of the nearby devices around me had been. Now, this is an active attack, and it was particularly effective against devices that were just trying to find a network to join. And I wasn't actually providing a Wi-Fi network. I was just creating the appearance of hundreds of fake Wi-Fi networks in order to find out which networks were really popular, which ones a lot of people had joined. Now, this sort of active polling for information could also be considered extraction of data. So in a fashion, we're going to be learning how to use Wi-Fi networks to extract information from nearby phones. Now, if you listen to my last instruction, then you should have removed most of these stored Wi-Fi networks in your device. But if you want to keep a couple there, you probably left your work network, your home network. I want to show how you can actually figure out whether or not someone has connected to a network before. So if you've also gone somewhere that you were not supposed to go and connected to the Wi-Fi network, this is probably an indication that anybody can prove that you're lying if they were to create a version of that Wi-Fi network that your phone then automatically joined. So let's go ahead and learn how this can identify VIPs or places that someone has been, and exactly how we can use our Wi-Fi nugget to create a swarm of networks. So we are going to be using the beacon command. So I'll go over here. I'm going to enlarge this and type beacon or help beacon. And we have a lot of the same arguments here. We can select, in this case, a channel to operate on. So that's the same as before, but most of these actually are kind of different except for the time, which specifies the length of our attack. So in this case, we are going to specify a SSID, and we can also use what's called a positional argument, meaning here we can see the format of how this command is laid out. So if I just want to type, for example, beacon test, I can do so, and it will create a beacon network called test. This makes it look to nearby devices like there is a real network here. So if you check your phone, if you check your laptop, you should be able to see a network called test. It's as simple as that. So in order to end it, I can type stop. And again, I'll just type help beacon in order to learn more about this command. So I've got an example of this that has every single common Wi-Fi network that I observed during my multiple war driving runs through Los Angeles. So I basically walked around and I collected all the Wi-Fi network names I saw, and then I ran a program that told me which were the most common around the city. I used this list to create a beacon list, something that I could run on the Wi-Fi nugget in order to create the illusion of the most common Wi-Fi networks I'd observed throughout the city and see which ones were the most popular for devices nearby. So I created this list and then uploaded it to our GitHub here. And if you want to try it, you can try the beaconswarm.txt, click on raw, select the entire command, and then just paste it here in order to run it. Now you'll see that there is a -mon. So really all we're doing is beacon and then putting all the different networks we want in quotes separated by a comma, and then adding the -mon at the end. Now, if you don't add the -mon, it will not monitor to see whether or not a device is trying to connect. And I'm going to go ahead and press enter, and I can see that now every single one of these fake Wi-Fi networks is appearing in the local area, and any device that's joined them before will generate an alert here when it tries to join. So I'm going to open my phone, and I can see there is a number of Wi-Fi networks here, like the Roadaway Inn and several other ones that I don't recognize. So I can see if any phone, in this case it'll be my phone, I think. Oh, I see Google Starbucks, FBI surveillance fan. If any phone attempts to connect, we should see an alert that tells us that there's an attempted connection here. Now, there also can be errors where if there are too many devices, if there's too many access points being created, it can make it so that it doesn't properly monitor them. So in that case, oh, here we go. We can see we have a device attempting to connect to Cricket Guest. We can also see there's a device attempting to connect to a guest. And let's see if there's any other connections. So if we want to see what this looks like from the victim perspective, on my screen, I'm going to take a look at nearby Wi-Fi networks. And I should see a lot of them once the scan is done. All right, DHS, let's try to join Whopper Wi-Fi. And obviously it's not going to work. Nothing's going to happen. But it will make an attempt, and then it should alert me on the other end if there's an attempt. So if this doesn't work, we can always paste in the command and then only select a couple of them. So let's say that I want to remove some of these all the way to here to improve the results. That should make it a bit more targeted. And sometimes by reducing the number of access points that we're creating, we're actually improving how this beacon swarm attack will function. So here, just to check, I'm going to attempt to connect to one of them. Yep, and instantly I can see a guest attempted to connect. Let's try Google Starbucks. All right, so we're getting better resolution now, and we can see that nearby devices are interested in these networks and are attempting to connect. Now, this is a constant cat and mouse game. And recently I found that some devices will warn you if they're encountering a network that they don't expect to be seen in this area. So that means that if a device is able to record your geolocation of where you are the last time you connected to a device, or the last time you connected to a network, it might warn you when you're joining a fake network that's extremely far away. Now, this is kind of an advanced feature. I don't see it being rolled out in too many places, but in this case, what this is able to tell me is if my device is automatically connecting to things like, let's say, maybe a hotel or something that reveals where I've been in the past, it will potentially sell me out to people who are interested in that information, who might be trying to find people who have been to that place before. So this attack allows us to take an active approach to data exfiltration. We're trying to squeeze information out of nearby wireless devices by interrogating them with tempting targets that make it look like a network they trust is nearby. Now, if you want to play around with this command, you can take the example from the GitHub repository and use it to format your own requests or fill in your own common Wi-Fi network names that are common to your area. But in the Los Angeles area, you'll find that a lot of these are extremely common, especially like Whopper Wi-Fi and some of the hotel chains, as well as flights. So be very careful when connecting to networks that are out in the middle of nowhere. If you start to see Whopper Wi-Fi while you're on a plane, then you know that somebody's probably running this attack. But so far, we have not created the real infrastructure for a real Wi-Fi network. We've created the appearance of a Wi-Fi network, but overall, I compare this to like a billboard. It doesn't actually create the full infrastructure, and it doesn't actually allow devices to join. It just monitors attempts to do so. So this is a notable difference from the attack we'll be doing in a little bit, where we're going to be talking about Wi-Fi phishing and actually creating a real joinable network. Now, the reason why a hacker might do this attack is also to figure out which fake network will attract the most attention. So if I'm a hacker and I want to create a fake network that I think a lot of people will join automatically, I can poll the audience basically and find out which of the fake networks I want to create will cause most devices around me to automatically join and then potentially give up the secrets of the owner or allow me to try a phishing attack. So in lab number 3, we are going to use an evil QR code to inject a Wi-Fi network into someone's phone. Now this Wi-Fi network is poisoned, and by that I mean it is a hidden Wi-Fi network, and that is going to change the behavior of their Wi-Fi device and make it extremely easy to track. Now, I think of this as like tagging a wild animal, in that you are tagging it with a unique network name, which allows you to track them in the future and even do things like be able to tell if they're in proximity by doing a Wi-Fi signal hunt and tracking down whether or not they're nearby. So that's pretty crazy to me for someone to be able to, for example, tell whether or not you're home by having you scan this on your smartphone and then be able to tell whether or not you're in a particular area, even from a distance. Now, because the range of Wi-Fi is about 1 mile with line of sight, that means somebody could stake out your home, your place of work. It's really crazy how much you could do with this attack, because in addition, if somebody creates the Wi-Fi network that they've injected into your phone, they can also arbitrarily take over your data connection. And that means they can change what you see online or cause pop-ups on your phone. So we're actually going to be doing that in our final lab, but this is a cool and interesting attack that you can do using the fact that QR codes are not human readable. So we're going to encode some specific information in QR codes, and because they can be encoded and formatted in different ways, we're going to be using the Wi-Fi format of data inside a QR code to store the information necessary for a device to automatically connect. We're going to be using the concealed hidden flag in order to make it so that the device acts a little bit more aggressively than usual. So it's perfectly fine to actually join a Wi-Fi network via a QR code under normal circumstances. We're just going to be setting it up so that it has a special flag enabled that makes it so that their device constantly screams out this Wi-Fi network name by default. So to generate this QR code, we are going to use quifi.org. This creates a QR Wi-Fi code that contains information that is specific for a Wi-Fi network we want someone to join. Now, here you can see the end result, and to the human eye, it just looks like any other QR code. And when you try to scan it, it does not alert you on most smartphones that this device is trying to join a hidden network. Instead, it'll just happily join it and then get confused when it doesn't exist. Now here on the bottom, we can actually, and partially hidden by me, we can see the information that's actually stored here. And this information has a special hidden flag at the end that means we are actually concealing, or rather the access point we're trying to join is concealing its name. So what is a hidden network and why would somebody want to use it? Well, a hidden network is basically a Wi-Fi access point that does not put out beacon frames. Now, we just used beacon frames in our last attack to create the appearance of a Wi-Fi network, and that made it show up anytime our device scanned for nearby Wi-Fi networks. Now, a hidden network skips this step. It basically doesn't put out any beacon frames. There's no billboard up front. You have to know that it's already there. And instead, it shifts the responsibility for calling out to the device that's trying to join it. So any device that wants to join a hidden Wi-Fi network has to constantly be calling out to see if it's nearby in order to connect automatically. And that is exactly the behavior we're going to exploit today when we were making this QR code. Now, if we were to scan this in a QR scanning app, we would see that there is a :S at the end, there's a H:true at the very end of this data. And that is exactly what allows us to make this a hidden network. So let me go to quifi.org. So we're going to put in our SSID. Thanks, 1Password. We're going to select the encryption, and this really doesn't matter. I'm just going to leave it set to WPA2, WPA3. Then we're going to set a key. And this is really whatever we want. Hello, let's do password 123. This doesn't matter. It could be gibberish. Really, the most important thing here is clicking on the hidden network. So there we go. We now have a evil QR code. So this is what I'm going to do. I'm going to take my phone. I'm going to hold it up. I can see Udemy class. It just tried to join it. So what happened here? Well, my phone added this to the trusted network list. So now it thinks that that is a great idea to join, and that it should, from now on, call out for that information as to whether or not that network is nearby. So it's going to constantly call out that network name. So if I do the probe reveal.txt, I'm going to copy this and paste it into our serial terminal. Let's see whether or not we're able to see my phone falling for this attack. So, okay, I can see a list of, yep, there we go, Udemy class. So as simple as that, I was able to inject this network name into the list of networks that's constantly being called out for by my phone. Now, I left these in from previous classes we did. Data Demons, I think that was Hope. DEF CON 69, I believe that was DEF CON, if I had to guess. But you can see that my device is now calling out for this network name that I just scanned without really any other interaction. It didn't ask me any other questions other than try to join network. So I found also that iPhones were doing this in a way that was so aggressive that it didn't really ask you. It would just, once it scanned it, it would just automatically try to join. And you had to be in proximity of the network that you were trying to remove in order to get rid of this from your trusted network list on an iOS device until very recently. So it was actually impossible to remove this hidden network from your iPhone until probably 8 months ago. So that's pretty incredible. And nowadays phones are a little bit more resistant against this attack, but it is still something that you can do against virtually any smartphone or anything with the camera that is able to scan a QR code formatted with this little H:true at the end. Now, because this is a standardized format, because devices are able to just scan this and then automatically know they're supposed to connect to a network, they don't warn the user that there's any change to the behavior of their device or the trackability of their device when they scan this. Even though this defeats the MAC address randomization that's trying to hide my device from hackers or anybody that's trying to track me, this effectively undoes it by creating a fingerprint of hidden networks that my device is always calling out for. Now, that is a huge privacy fail. So if you have any hidden networks stored in your phone, you should be able to identify them with this scan. You should go through and make sure to remove those, including the one that you just added, by following this guide, because it is a huge source of trackability and it makes it so anybody can track you from place to place, build a profile based on your Wi-Fi fingerprint, and potentially take over your phone's connection. Now, we're going to do that in the next in the next lab, by creating an access point. And this is something that we're going to do a phishing attack with, but a more sophisticated hacker could actually use this to take over your data connection and start sending phishing pages that are designed to trick you into signing into important accounts and potentially giving up critical information. So that is the majority of this lab. If you have any other questions about creating malicious QR codes, you can do a little bit of research on ways that people have done this in the past, because obviously people are also creating QR codes in other ways, such as perhaps using a QR code sticker to get payments to be redirected to a fake website. So what can you do here to stay safer? Well, make sure that you don't scan QR codes that you don't trust, whether you are in public or in a sensitive place that you don't want to be tagged in. Make sure that if you're scanning a QR code, it doesn't have that special flag at the end that indicates that it's a hidden network. You can always use a QR code scanner that doesn't automatically join the network and just displays the raw data in the QR code. And that's a great way to make sure that you're not accidentally introducing networks that you don't mean to into your trusted network list. The trusted network list is a very serious thing. It actually greatly influences the behavior of your device over Wi-Fi. So making sure that list doesn't include devices or networks that you don't actually trust is really important for keeping your Wi-Fi devices clean and making sure they don't sell you out when they see a network that they've connected to in the past. All right, let's go through the final lab. In this lab, we're going to go over an attack that I've actually been a victim of in the past, and we're going to talk about Wi-Fi phishing. Now, Wi-Fi phishing has gotten pretty sophisticated, and this is an example of the phishing page that I actually saw when I fell for this years ago. Now, I used to work for a startup that was in a mixed-use building, so some of the units were apartments and some of them were businesses, and the people who were in the apartments loved to get free Wi-Fi. So somebody learned how to use a tool which disconnected our Wi-Fi service or interfered with it in a jamming attack, which is possible to do and very easy, and as a result is something that you should be aware of when you are learning about offensive Wi-Fi attacks. Now, this jamming attack was coupled with the creation of a new Wi-Fi network that had the same name as the Wi-Fi network they were jamming. However, it didn't have a password. And when we were trying to work, we got annoyed and attempted to join this open Wi-Fi network, we were presented with this. Now, this pop-up looked very official, and it said that there was a firmware upgrade underway, and that we needed to type in the Wi-Fi password in order to proceed. Now, I typed in a gibberish password, and it didn't work because the program was actually trying out the password in real time, and it prevented me from typing in the wrong password by actively checking it when I was just typing in nonsense. So that kind of convinced me, oh, okay, like this actually knows the real password. And as a result, I typed in the Wi-Fi password. And the hackers there were able to check, make sure that it really worked in the network they wanted to break into, and then discontinue the jamming attack. So to me, it looked like I had successfully updated my router via a firmware update. Now, I patted myself on the back and thought I'd done a great job of keeping the office secure that day, but I had actually given out our Wi-Fi password to a bunch of random hackers. Now, fortunately for me, they just used that to game and slow down our Wi-Fi, but in a more malicious situation, anybody could use this to gain access to your network devices and start trying to break into things, or possibly sell out your Wi-Fi connection and use it as a proxy for all sorts of criminal activity. So if the FBI were to knock on your door and ask you why a bunch of fraudulent credit card transactions were running through your Wi-Fi network, then that could be why. So we obviously want to protect against these sort of phishing attacks. And the best way to do that is to show exactly how easy it is to create one of these fake Wi-Fi networks. So we're going to use another function, the access point function, to learn exactly how this attack works and see what it looks like when your device joins a captive portal. So the anatomy of Wi-Fi phishing is such. We are going to first kick the victim off of their real Wi-Fi network, which we are going to simulate in this case, but is very easy to do. And then we're going to create an access point with the exact same name as the target network, but no password. We're going to pretend that the router needs an update or give some other plausible explanation for needing the Wi-Fi password. And when the victim connects to the access point, we're going to be able to not only pop up a phishing page, but also get a notification telling us that a victim has connected. When the victim types in the Wi-Fi password, then we're going to stop blocking the legitimate Wi-Fi network. And the victim should hopefully get a fuzzy feeling that they've done something to improve the security of the network that day. So we're going to create our fake network by using the AP command. And if we type help AP, we can see all the various flags that are available to us. First, we have a positional argument, which allows us to set the name of the network, and that is the SSID command. But again, this is positional, so we can just make it anything in quotes following the AP command. Next, we can set a password if we want to make this look like a network that has a password. For this example, it's important that the password is not set. So if we just leave this blank, then this will be created as an open Wi-Fi network. Next, we can specify if we want to make this a hidden network. Now, we don't want to do this in this example because we want this to be visible to other devices in the area in order for them to join it. So we're not going to use this flag. But if we want to, we can use the -ch channel to set a common channel just to pick up a little bit maybe on how quickly this will be detected. Aside from that, we can also use the BSSID command to set the MAC address. So we can actually use this to make this look like any device we want to. So if we wanted to make this look like a very scary, like Lockheed Martin tactical network system, we could go look up what one of their MAC addresses is on any one of the MAC address lookup websites, and then specify that here. And the beacons that we're sending out for this network will actually look like it is from a device from that manufacturer. Now, manufacturers actually set the first half of any MAC address. And that means we can use this command to spoof the manufacturer of the access point that we're trying to create. So this is a really good idea if I'm a hacker to first do a scan and identify what brand of router that we're trying to spoof here. Because, you know, if this is like a Linksys router and we're spoofing just a random MAC address, then we might not fool somebody who's a little bit more sophisticated. But if we do a scan and then we spoof a MAC address that matches the brand that we're trying to do this attack against, then that is going to be a lot more convincing here. So let's create a phishing network. I think I made this slide originally when I was in Germany, so let's go ahead and do this one in English. But here, I'm going to type help AP. And we can see all the various commands again here. I'm going to type AP not a hack. And what's going to happen is when I attempt to join this, it's going to pop up on my screen. It's going to look very official, and it is going to be something that anybody who maybe didn't understand exactly what their router's firmware looks like might fall for. If it were dressed up a little bit. Now, we tried to make this as dumb as possible, and in doing so, we made it so that it's not likely you are going to fall for this attack. That is a choice. It does not need to be that way. If somebody wanted to, they could obviously spruce this up, add a better phishing page, and make it so that it's more convincing. But in this case, I have a pop-up, it's asking me for a password, and clearly this is not going to convince people to dump their deepest, darkest secrets into it. However, it is a good example of what the pop-up looks like. It's from the operating system, it's very official, and it looks very much the same on a mobile device. So here we can also see in our serial terminal, we have confirmation that our victim has connected. And we can see the MAC address and the IP address of our victim here. Now, when I type my password in, I can hit submit, and I get the password delivered to me as the attacker right there. Now, in the example that I mentioned, we also have the ability to do deauthentication. So if I type in help, there's a long list of commands here, but one of them is deauth. So if I combine these commands, and there we go, if I combine these commands and I specify a device that I have found in a scan, so if I type scan as well, I'll run that while we're looking at this, I can specify any of these networks for a deauthentication attack and actually run these concurrently. So I can send out deauthentication packets, which are going to cause a jamming attack on the target, and also create a fake version of that network with no password. Now, I'm not going to go over the deauthentication attack because, well, for one, it's so simple, it doesn't really need much documentation, but that's the one where I really have to urge everyone to refrain from using it unless you absolutely need to. It is incredibly noisy. That is probably the most often abused command. And if you target the wrong device, you can get in a lot of trouble for kicking off a device that is very, very important. So if I type help deauth, I can see these are all the different available commands to select a deauthentication target. In this case, I see I have a number of different access points here. If I select number 2, I could type Deauth AP2, and this will kick any devices that are connected to this Wi-Fi network off of the network until I type stop. So again, you can simply combine these two commands in order to run a Wi-Fi phishing attack, which both kicks a device off of the network and then offers an alternative network, which is not a real network in that it will not provide data. However, it is a network that will allow them to connect, generate a pop-up, and then type in a password in order to steal information. So we kept our example super general. We did not make one that is going to trick anybody into giving up their secrets. However, if you wanted to recompile this, if you wanted to change the look and feel of this, it is totally possible to do so. It's an open source project. The source code is available on GitHub. And obviously, I don't want to encourage that sort of thing. But for anybody that's been the victim of this attack, you might recognize how this captive portal looks quite official. It's something that most people don't really know exactly what it looks like, and we're used to seeing this on planes and hotels and in other spaces where you might need to connect to a captive portal, like maybe a library or something, before getting internet access. So what is to be learned from this example? If you have a disruption in your Wi-Fi connection and then an open Wi-Fi network suddenly appears, you should be very skeptical. This is often a tactic to make it easy for hackers to gain access to your Wi-Fi password without actually needing to crack it. So if you have a very strong Wi-Fi password, this is something that could give a Wi-Fi hacker access to your Wi-Fi network. At that point, they can do all sorts of bad things like take over your network, maybe rent it out to other hackers who are going to do carding or other things on your network that is very risky and that they wouldn't do on their own network. So it is important to make sure you don't accept one of these captive portal pop-ups as something that your router is doing in order to facilitate an update or something else that requires your Wi-Fi password. Now, maybe if your router is malfunctioning, you would, join it and then provide the router password, which is a different administrative password, in order to start updating it or do other fixes. But you would almost never use your Wi-Fi password to gain access to any of these functions. So be very, very skeptical when typing your Wi-Fi password into any website, because that is something that is not very, very common. Another thing that would have disabled this attack or made it a bit more difficult is a VPN. Now, a VPN will make it so that it creates a direct tunnel between you and the Wi-Fi connection or the data connection that you're trying to join. It makes it a lot more difficult to intercept the connection and generate pop-ups or try to kind of like rifle through the internet connection and see exactly what that person is up to. If I were to be connected to that fake Wi-Fi network for long enough, my computer will try to update, different programs will try to connect back to their servers, and the attacker can make a list of all the different applications running on my computer and all the different apps installed. So it's important to make sure that if you're going to be using networks in public, you use something like a VPN to at least limit how many companies have access to that data, because otherwise it's possible for a hacker to man in the middle of that and start learning about your devices or generate pop-ups. Now, I also want to go back to deleting any open Wi-Fi networks stored in your phone. While it's understandable to store some networks in your phone, you don't really need, that old hotel Wi-Fi network or that airline network, or even some of the networks that have a password that are maybe a little bit more revealing than you would want them to be of where you've been and what kind of information you might be privy to. So if you work for a spicy organization, or if you consider yourself to have maybe joined the Wi-Fi network in a place where people would be interested in knowing you were there, then make sure you go through and delete these so that your phone isn't coughing up that information either passively, where it's just calling out that data and anybody can hear, or in an active kind of exfiltration scenario where somebody's creating a bunch of beacons which are drawing that information out of your phone. Hopefully, by going through these steps, you can keep your devices from accumulating long lists of useless Wi-Fi networks that both identify you uniquely and allow you to be tracked as you go from place to place, and also create cracks in the armor of your phone that allow somebody to take over your data connection, potentially pop up phishing pages, or start making a list of all the different applications you're using or websites that you're visiting. So, Back to the QR codes, make sure that you don't scan them if you don't understand what is in them. Because QR codes are not human readable, they are perfect for hackers to take advantage of. So when it comes to scanning things for payment, we've seen instances of fraud where people are putting malicious payment links, but also clearly they can be used for Wi-Fi surveillance. So if you are scanning a Wi-Fi QR code and you notice the hidden tag, make sure that you're not storing it to your phone. And if you've already scanned it, it's relatively simple to go in there and remove anything that's causing your phone to put out unnecessary information or make your phone tag like a wild animal. So if you want to teach other people, you can also take a look at some of our kits online. We have a number of different Wi-Fi nugget related products that not only upgrade your nugget, but also allow it to operate off of a battery. So if you want to do things like Wi-Fi signal hunting, or if you have a Wi-Fi nugget project that requires you to plug it into sensors, there's a number of great things we've created on the retia.io store that allow you to continue your learning or introduce other people into cybersecurity for the first time. You can find our nuggets, add-ons, and online classes at both retia.io, on my own hack.gay, and also on nugget.dev. Thank you very much, everyone. If you have any questions, you can check out our Discord server where there's lots of other people that have taken this class before you, many of whom are happy to answer questions if you don't get a response back immediately. You can also find other people who might be asking questions on the Security Forward and Retia live streams. These are twice a week on Wednesday and Friday. So if you have any questions, you can always join, ask live, and get responses back from me, as I am streaming every week and love hearing from people who have taken this class. Thank you, everyone. Stay safe and make sure to keep your Wi-Fi devices safe from hackers by following these 4 labs.